This video summarizes an analysis workflow. The steps and outputs are marked in the center of the diagram, and software tools are marked on the left. Impactful survey analysis starts with a good research question. A good research question is focused and answerable. Some people use the finer criteria to evaluate a good research question. F. Feasibility. Can the question be feasibly answered with the available sample size, time, resources, and statistical skills of the team? I. Interesting. Is the question interesting to policymakers, funders, program implementers, and most importantly, you? N. Novel. Is the research question novel? Does it extend, confirm, or refute previous findings? E. Ethical. Is the study design ethical? Does it ensure minimal risk to participants as well as informed consent and confidentiality? R. Relevant. Is the research question relevant to policy, program management, patient care, or scientific knowledge? If no one cares about the results of the study, it is probably a poor use of your limited time and resources. It is important to spend extra time developing a good research question in conjunction with decision makers and after becoming familiar with the scientific literature, because a good research question is the foundation of an impactful study. There are many formats that a quantitative research question can take. Here are two common formats. A general explanatory research question has the format, what factors are associated with outcome? For example, what social and demographic characteristics are associated with intimate partner violence in Rwanda? The researcher develops a model with multiple factors that are potentially associated with the outcome, and narrows down which key factors are most important based on the magnitude, direction, and statistical significance of the associations. Another common form of research question is a hypothesis test. Hypothesis test questions are formatted, does X affect outcome? For example, does having comprehensive HIV knowledge reduce risk of HIV infection? To answer this type of question, the researcher tests the effect of one predictor on one outcome. The term predictor is used loosely here. To predict something implies causation, and cross-sectional survey data cannot be used to determine causation of health or social outcomes. But a hypothesis test does provide evidence that a factor is or is not associated with an outcome after controlling for other potential confounding factors. Confounders will be discussed further in a multivariable regression video, but in short, confounders are factors that are associated with both the predictor and the outcome, which make the two variables appear to be statistically correlated even when they are not. If we do not control for confounders by including them in the model, then we might incorrectly estimate the magnitude, direction, and statistical significance of the relationship between the two variables of interest, and ultimately arrive at a wrong answer to our research question. Once the questions and associated research objectives are clearly stated, a conceptual framework can be stated in words, but I will encourage you to draw a picture of the factors or variables involved with the research question, with arrows showing how they are related. The conceptual framework can be simple as the diagrams that we just saw. The video about developing a conceptual framework will provide a few more templates to help you outline a conceptual framework. Deciding which variables to include in the conceptual framework requires background research. I usually start by documenting my own assumptions and knowledge about the research question, then update the layout and the variables in the conceptual framework based on a systematic literature review. Development of a conceptual framework helps you identify which variables you need to answer the research question and to decide which survey datasets you will use for the analysis. Household survey datasets tend to be very large with thousands of variables, so it is helpful to document the key variables at this early stage before you open the dataset and get severely sidetracked. Without a conceptual framework to focus you, you will get sidetracked. Many of these surveys are conducted on a regular basis across multiple countries, including the demographic and health surveys supported by USAID, the multiple indicator cluster surveys supported by UNICEF, and the STEP survey on chronic disease supported by the World Health Organization, to name a few. Once you know which variables you need and the time frame and geographic coverage of your research question, it will be straightforward to identify which existing survey dataset is best suited for your research. It is only at this stage that we open the dataset and Stata. The next phase is to prepare the analysis dataset. This involves identifying variables from the survey dataset, summarizing those variables to understand their definitions and distributions, and renaming, recategorizing, and combining variables as needed for the analysis. After the analysis dataset is prepared, we describe the study population. Results of the descriptive analysis are usually summarized in Table 1 of a manuscript. Table 1 might simply provide summary statistics of the overall population, though in some manuscripts, Table 1 describes the characteristics of 2 or more subgroups, for example, an intervention group and a comparison group. In the bivariate analysis, we look at relationships between each of the covariates and the outcome using statistical tests. This step can serve as a filter, helping us to decide which variables are even worth testing in a multivariable model. We also use bivariate statistics to make comparisons, for example, to test if an intervention group and a comparison group had a similar distribution of age and gender, which provides evidence about whether we can fairly compare the two groups. In a manuscript, we usually report bivariate statistics in Table 2. Collinearity occurs when two covariates in a multivariable model are highly related. Usually this is because two variables represent the same thing. Basically, one of the variables does a good job explaining variance in the outcome, leaving little leftover variance to be explained by the other covariate. As a result, the model becomes unstable. To produce parsimonious, efficient multivariable models, and to prevent strange, unstable results, we test for strong associations among covariates and remove any collinear covariates from the analysis. By the time we start building a multivariable model, we have narrowed a list of meaningful covariates that are not collinear. We fit a model with all of these remaining covariates and use manual backward stepwise regression to narrow down which covariates are most important toward explaining the variance in the outcome. Producing a multivariable regression model is somewhat mechanical. We follow a standard process like a recipe to arrive at a final model. How we interpret these final results and relate them to the real world varies widely. In this part of the analysis, you perform statistical interpretation of the model output in terms of the magnitude, direction, and statistical significance of the results, but you should also extend the interpretation to think about the story that the data tells. The story is usually comprised of a few key takeaway messages that are discussed at the end of a manuscript. This analysis workflow will lead to robust statistical analysis of any existing survey dataset, and will serve as a roadmap for courses taught with the populationsurveyanalysis.com materials. Go to populationsurveyanalysis.com for a PDF version of this video and other learning materials that support your analysis of a population survey dataset.